Welcome to MRU E-Learning powered by Mallareddy University. Hi everyone. This is Dr. Sivasubramanian, Associate Professor, Department of AML. And today we are going to discuss about the topic impact of AI in cloud compute. Of course, we are all familiar about the services provided by AWS or any form of cloud. So today we are going to discuss about what are major challenges and how it is being carried out by AI algorithms. So when you're going to see these major challenges like intelligent resource management, performance optimization, enhanced cloud security, cost optimization, what is the predictive maintenance and industry specific transformation. So apart from this, we have more challenges, but we are going to focus only about 4 challenges today and how it is being carried out by AI algorithms. So we are going to see this cloud services, cloud computing without AI. So whatever may be the services we are going to consider, for example, we are talking about EC2 or EBS or CloudWatch, whatever may be. So what is happening is each services will have a static value, that is static threshold value. So for example, you just consider virtual machine. So what is the threshold value, for example, in case of virtual machine is 80% or 75%. So like this, the static value is fixed. So whenever the demand comes or whenever the resources reaches the level 75, it is going to increase the load. So this is what happening in cloud computing without AI. So it is going to fix the static value, crosses that particular threshold value, the demand will be. But whenever we are going to great spike, so for example, if 1 lakh requests are coming for that particular request or service, so in that case, process will slow down or the throughput will be very less. So to overcome these difficulties, AI algorithms are used in each and every services. So first we are going to discuss about how this AI algorithm works in case of intelligent resource management. So whenever you're coming for this resource allocation, and we know about resource allocation in terms of OS, the same method, the same thing is followed in case of cloud computing also. So whenever you're talking about resource, it may be software or hardware. Whenever you're going to consider hardware, the memory, software means OS, like this resources. So any service comes, any service requests for that particular resource, the cloud architects has to provide the resources properly, on time, on demand. So whenever we are not going to include this AI algorithm in this particular resource allocation, as I said earlier, the number of demand, that's a threshold value. So based on the threshold value, it is going to increase the number of resources or it is going to decrease the number of resources. But whenever you are going to introduce AI algorithms, like AI algorithms or ML algorithms or deep learning or deep reinforcement learning, so this resource allocation is more optimized, more intelligent, we can say. So this is about predictive rules and static thresholds. As I said yesterday, as I said now, it is going to have with the predictive threshold value, which is already predicted, over or under provisioning and high cost. So whenever we are not going to use AI algorithms, so these are all the limitations we have in traditional cloud computing, like delayed responses to demand spikes. Manual tuning is mandatory often to change the threshold value based on the timings. So for example, in Sundays or any exam times, the number of requests or number of demands will be more. So manually we need to change the threshold value. So these are all the limitations. So how can we overcome these limitations using AI algorithms? So AI driven intelligent resource management carry out these 5 steps. First one is about telemetry. So telemetry is a continuous monitoring and logging the status of all devices, that is status of all resources in case of whether it may be a CPU or memory or OS or whatever may be. So it is going to, this particular process, the telemetry process is going to monitor or log the status of all resources. And the second step is feature store. This will be stored for a future, that is further references. And third step is we are going to introduce the ML models. So here models means ML algorithms, as we are going to discuss now. So this algorithm, this model is going to decide what action shall be taken, which is the what are all the possible actions that are possible for the available load. That is what the major thing in case of this ML models. And next one is orchestration. So this process is entirely about which action should be taken for that particular scenario. That is what the meaning for orchestration. And finally the actuators. So here it is going to give the performance. In case of actuators, we are going to, it is about these actions are being recorded, are being looped backward for that particular scenario. Why? Because of course we all know the AI algorithm works on the patterns. So this actuator is going to give the patterns. So this is the sequence of steps that is being followed in case whenever we are going to talk about AI system in cloud computing. That is AI algorithm in terms of cloud computing. So first one is about telemetry, which is going to log all the status of all devices. Second one is feature store. It is going to store, it is like a centralized repository to store the status of all resources or status we can say. And the third part is the core part. Here the original process is going to happen, what algorithm can be used and what is the possible outcomes, what are the possible decisions it is going to take as per the algorithm. And fourth one is about orchestration. So here it is going to decide which output is going to be followed for the particular scenario. Finally, the actuators. So first we are coming for this in resource allocation auto scaling. We all are familiar about auto scaling. Here 2 minutes about auto scaling. This is about auto scaling of resources we can say. So for example, if in that 1 hour we have 100 requests. So based on that, the number of resources will be allocated. So in case if that particular threshold value crosses the 75% of limit, it is going to increase the number of resources. Or if a request comes less than threshold value like 45 or 42, it is going to reduce the number of resources. So this is what auto scaling is about. So automatically or dynamically it is going to increase or decrease the resources for the requests. The same action, the same AI algorithm is going to follow in case of auto scaling also. It is going to follow telemetry, prediction, decision logic. We are much focused about this third part, which is going to be decision logic. So what are all the actions that can be possible for that particular scenario, and scaling action. So based on the requirement, it is going to scale up or scale down the number of resources that are required for the demand. And the last part is most important, is going to be the feedback loop. It is the feedback loop. It can be a reward or a negative thing. So it is being recorded for the future references. So telemetry, as I discussed about, it is going to monitor the CPU load, the state of all resources, whether it be a OS or number of input data or timing in which the requests are in demand. And about prediction, ML predicts upcoming demand. It is going to store or it is going to calculate or it is going to predict the demand from the previous statistics. That is what prediction is being done. And third one is about decision logic. Scaling action, that is increment or decrement of number of resources. And finally this is just an example, auto scaling for festival scale. For in case of festival, this is just an example of how auto scaling is done and what is the impact of that. So for example, if you're going to consider any peak hours like or peak days like festival events or like Diwali or maybe exam times, especially in case of exam timings. So for example, let us consider the peak hours maybe evening 6 p.m. to 12 a.m. Let us consider this peak hours. So for example, 100 requests are coming. If you're not going to use AI, the responses or throughput will slow down. In case of AI implemented AI algorithms, it is going to increase the response time. It is going to decrease the response time. So these are all the benefits in case of auto scaling whenever you're going for this AI, whenever you're going to use AI algorithms. So zero downtime and smoother user experience. So there is not even a millisecond delay whenever for the response is concerned. No over positioning or under positioning. Of course, the second one is important. So we are not going to, this AI algorithm is not going to allocate more number of resources or less number of resources based on the demand. It is going to allot the resource as in crisp or equal demand. Fewer crashes and improved reliability. Fewer crashes, cost efficiency. Of course, we are going to discuss about this cost optimization as a separate challenge. So request latency. So these are all some of the benefits we can accept or we can realize whenever AI algorithms are used in case of auto scaling. And next one is about the load balancing. So load balancing is about, so for example, if you have 3 or 4, let us have 3 servers as mentioned in this particular diagram. So first server is having a load of 85, tasks are being run. Remaining 2 servers, one is 40 and next one is 30. So for example, if any more request comes or if any more demand comes, instead of taking or giving the load to this server A, it is being distributed to 4 and third, that is second and third, that is B and C. So this is what load balancing. So for example, if both server C and B is reached the limit, again we are going to introduce one more server so that the load can be distributed evenly. So instead of giving a particular server the hectic load, this load balancing is going to give equal distribution of workload for all servers. That is what about the load balancing. So these are all the benefits when you're going to implement AI in case of load balancing. Faster response time. Of course, it is mandatory. So whenever you're going for this today's scenario, faster response time. avoidance of single server workloads. That is what the core concept of load balancing. Stable streaming and web services. In case of any games or movies or any important meeting, live streaming, AI is going to give much impact in this. That is stable streaming and web services. Improved user satisfaction. Of course, this is most important challenge that the cloud computing is facing, the customer experience. Average response latency is being reduced. Server utilization variance. So of course, the load balancing is about server utilization. So for example, if you're going to consider 3 servers, server A, server B and C. So for example, if 10 demands, 100 demands are there, instead of giving 100 demands, for example, if you're going to give 100 demands or 100 works to the same server, so in that what is happening, server B and C are wasting their time. The resource is not being properly utilized. So to overcome that, the 100 demands are being splitted into 3 evenly poised number of demands so that the equal workload will be given for all servers, so that the server time will not be wasted. And session success rates, time to redistribute load. So all these things will happen in case in less than a millisecond. And next one is smart scheduling for VM and container placement. So before going for this, I would like to talk about what is VM and what is container. So both are like a virtual concept only. Virtual machine means it is going to virtualize the hardware, whereas container is also virtualize the software. So difference between this VM and container is about VM is a heavy weighted virtual concept we can say, whereas container is the light weighted concept. Why? Because VM is going to have an instance of OS which cannot be shared through other instances. So that's why we are calling VM as the heavy weighted we can say. Whereas container is going to virtualize the software, so which can be shared among the instances. So it is called as a lightweight we can say. So whichever the application which is not critical, in that case we can go for container. Wherever intense application can use this virtual machine. So that is what the small introduction about this VM and container. What kind of works for that, what kind of time that is work can be allocated, it is mentioned here. CPU memory. For example, if you're going to consider this database activity work, so for that we need to allot virtual which is having more storage, Why? Because when you're going to discuss about this database, it is going to occupy the more number of storage. So for this, we can go for this VMs we can say. So for this particular database applications, that is database oriented applications, we cannot go for the containers. We can we can go for this VM. So similarly, we are going to split for which kind of applications. For example, if any website orient, that is website applications, any small websites, for that we can go for this containers services. Based on the application or based on the intents of the application, this containers or VMs are segregated. So again, it is going to smart scheduling, we can say, training and container placement. So these are all the sequence of steps that is being followed in case of AI. Of course, we all familiar about the scheduling in case of OS. The same scheduling is followed in case of cloud computing also. Focus on AI in case of scheduling. So these are all the sequence of steps that is being followed. First one is identify workload type. That is what I was discussing. The application is intense or less intense, critical, which requires more number of memory. So likewise, it is going to be splitted. That is identify workload type. That is what the first one we are saying. So classify workloads as ML training, ML inference database, whatever may be and access node capabilities. So for example, this is the second step is more important. We need to identify which node, for example, if you're going to have number of nodes, which node is having how many number of loads. So that we need to finalize. That is what access node capabilities. So evaluate node 1, which is going to use only for higher memory. Node 2, a balanced CPU RAM, and third one, CPU equipped. So of course, the work which is coming, our application can be segregated based on any one of this particular concept. Either the application requires more memory, or application requires less number of memory but immediate response, and third one is CPU equipped. So the works or the applications or demand will be splitted based on these 3 categories. After that, match workload to the node. So now we are going to match whatever the work comes, whatever the request comes, we are going to match, or we are going to give the load to the particular node alone instead of giving any chain node, and place containers, database containers to node 1, web server to node 2, M1 to interface to node 3, and finally feedback monitoring. This is going to be the. So this is how this smart scheduling can be done in case of virtual machines and containers. So intelligent resource management, this is the major challenge that we covered now. This is the sequence of steps that is being carried out whenever we are going to implement AI algorithm resource management. So telemetry collectors, feature scope, prediction engine, orchestration and decision engine, actuator layer, and finally monitoring and feedback. So this is the sequence of process that is being carried in case of AI algorithms in case of cloud computing. And this is simple algorithm. How it is used in cloud computing. This is deep reinforcement learning. This particular diagram shows about this is the normal cloud. So in this cloud, every status is stored. What is the CPU? That is what is the load for CPU? How many memories are there? And what are all the resources allocated? That will be stored. And that particular status will be given to this DRL, that is deep reinforcement learning algorithm. So that is what the state collection. And the step 3 is DRL agent. This is the agent, we can say. Agent means it is going to create a model. So based on the decision, it is going to decide what actions can be. So and step 4 is going to be, these are all the possible actions which is given by the ML algorithm or a deep learning algorithm, you can say. So what are the possible algorithms in case of resource management? We can scale up or scale down, or via migration, we can transfer a particular workload to another virtual machine also. So these are all the possible actions, that is scale up or scale down and scale, that is virtual migration. And step 5, we are going to apply the action. So based on the prediction or based on the history or based on the pattern, we are going to, that is algorithm is going to apply the action, whether it needs to scale up or scale down or migrating something. And step 6 and 7 is going to be act as an input for the future, we can say. That is reward. The new state generates reward signal that measures how good was action is. And finally, the learning loop. So these two, that is last 2 steps is primarily focus about the record of actions that is being carried for the particular instance, and it will be saved for the future references. So this is how this deep reinforcement learning is applied in case of intelligent resource management. That's it about the first challenge, that is resource management. Second part, another challenge, that is next challenge is about performance optimization. So nowadays this cloud architects primarily focus on all challenges. Of course, they might be facing major issues whenever the AI algorithms are not utilized. How far the challenge they are going to face, so that what has happened day by day, these cloud architects are trying to implement AI algorithm to increase the performance. So again, the same set of sequence, AI driven performance optimization, system monitoring, collect all the metrics like CPU, latency, errors, and user experience data in the real time. That is what system monitoring. AI analysis. So of course, use machine learning models to detect anomalies, trends, and root causes. Analysis. We are going to analyze. That is, AI algorithm is going to analyze. So what are the root causes, anomalies, or any deviations, and all these things. And predictive insights. So this insights is being gathered from the patterns or previous history, we can say. Forecast capacity needs, performance degradation before user are affected. So it is going to again give the load in a distributed manner. Automated action, execute actions such as scaling, configuration tuning, and traffic routing. By default, as a result, we are going to get the performance improvement. So these are all the real-time metrics collected by AI in case of performance optimization. First one is CPU utilization. So it is going to, for example, a week of time. So what is the CPU utilization in that particular week of time? So that data is being collected by this algorithm. And memory usage, how much amount of memory is being utilized, how much amount of memory in the RAM is being utilized, whatever may be. And disk IO, that is how many number of IO operations are being done for a particular second or a particular day or a particular hour. Network bandwidth, of course, it is very important. It observes for the allotted bandwidth, how many requests granted without any disturbance. And application response time, of course, it is much required for the customer satisfaction. User session counts. So a week of time, how many sessions or how many users are requested or using that particular. So these are all the metrics that is being collected by AI. Predictive workload forecast to provision. Again, this is different given in different diagram. Same thing. So predictive scaling for an online learning platform. So whenever you're going for this online learning platform, how the predictive scaling will be done by AI. That is what this particular steps is about. Predicts daily evening spikes and even bursts. So of course, it is going to divide the day into some 3 or 4 durations like morning 9 to 12 and 12 to 4 and 4 to 10 and 10 to 12. Like that it is going to divide. So predicts daily evening spikes and even bursts. So that is very much important. Learn 7 p.m. to 10 p.m. pattern launches announcement and new course bursts. Starts extra instances 30 minutes before peak. So whenever the load trying to increases gradually, so before 15 to 20 minutes, extra instances can be created so that requests cannot be wait or user cannot no need to wait. No login delays or video buffering. That is again another important thing. Combine forecast with cost awareness scaling. So wherever we are going to talk about the optimization, we are going to include this one parameter which is called as the cost optimization. Actualize predicted and actual traffic. So and this is going to be the output, or that is what whether our prediction is successful or not. So actual prediction is, for example, in the peak hours between 6 a.m. to 6 p.m. to 12 a.m. it is going to be considered as a peak hours. The number of workloads that is predicted by AI algorithm is, for example, 1 lakh. So for example, the number of demands is actually 50,000. So in that case, what is happening? Our prediction is entirely failed. Why? Because 50,000 predictions or 50,000 resources, 50,000 amount of resources is going to be wasted. Why? Because it is not being utilized. So in this case, prediction is entirely failed. So that is going to be recorded, visualize predicted and actual time. Next day, this AI algorithm will not do that particular mistake. It is going to predict appropriately. For example, if it is predicting 1 lakh requests, so if the actual request is about 85,000, 95,000. So this prediction is automatically changing as the day progresses in future course. So you can traffic detection, it is just an example in OTT streaming network. So in South India, it is going to be peak hour is 8 p.m. and 11 p.m. So in that peak hours, we need to, that is AI need to predict something more, and it needs to allocate more number of resources. Mobile streaming exceeds desktop. Of course, nowadays this mobile is giving much impact in all the fields we can say. This cloud architects mainly focus about this mobile streaming also. So these are all some of the examples we can say under what situation, what kind of decision can be taken. And this is just a small comparison, manual versus AI performance comparison and sale day impact. So decision style is reactive in case of manual. Of course, we all know the scale up or scale down is based on the reactive process. Whereas AI, it is going to be proactive. It is going to predict in advance. And adjustment time minutes to hours, whereas in case of AI, it is milliseconds. Adjustments here refers to allocating a proper resources to the requests. Accuracy, again, whenever we are not going to use this AI in case of cloud computing, accuracy is going to be rule-based. Rule-based means we are going to fix the system, we are going to fix the process. So it is called a static, I'm saying. Whereas in case of AI, it is based on the machine learning algorithm what we are going to use. And scaling, again, the scaling is fixed here, whereas in case of it is adaptive. That keeps on changing based on the situation. And human involvement is high in case of manual, and it is minimal in case of AI algorithms. So this is just a comparison we can say. And this algorithm is again the example. This algorithm is called as a ant colony optimization. How this algorithm works, algorithm giving impact to this particular performance optimization. So let me say 2 minutes about this ant colony optimization. Actually, this particular algorithm is used for finding the optimized path. So here 2 paths are given. So this is one path and this is here. And so for example, here ants are there. They need to fix the foods. So either the ant can follow this particular route or this particular route. So whichever the ants that is going in this route takes much time. And whichever the ants use this particular route is going to have less time. So this is what the ant colony optimization. So what is happening in case of real time, this ant is going to spray some ferroform wherever it goes. Ferroform is like a chemical substance. It is going to lay as in their path. So based on that smell, based on that particular sense, it is going to change the path. So that is how this particular algorithm used in case of resource optimization. And that is what performance optimization. So you can see this algorithm. First one is initialization. Pheromone trials represent resource allocations. So for example, number of resources are allocated. So that is what the first step. Second step, resource allocation. So here number of resources allocated. Second step, resource allocation means how many number of resources are allocated. That is what the resource allocation. Request and choose resource based on the level. And third one is evaluation. So whatever the resources that is being allocated, is it optimal one or not optimal one? So like that it is going to evaluate. So that is what access performance. It is going to check the cost, latency, throughput of all the allocated resources and pheromone update. So now it is going to update, reinforce good allocation. More pheromone means that what we are going to analyze. So how many number of resources are allocated for that particular time or particular hour. So based on that we are going to update. So how the update is being done based on this particular performance. It is going to check the cost, latency, throughput. If the cost is more, if latency is high and throughput is throughput is less. So in this cases it is going to optimize. So which can be the optimized one. So like that it is going to update. And the next one is that is a weaker criteria or weaker, that is what weaker performances, that is what that is less optimal allocation is going to be removed. And convergence, repeat until optimal resource allocation is used. So here the core is about first we are going to initialize the resource. First we are going to initialize the resource. Then we are going to allocate the resource. Then we are going to evaluate based on the different parameters like cost, throughput and latency, whether our allocated resources is much optimized one or not. So if it is not optimized, we are going to follow the next step. We are going to use that is AI algorithm is going to use the another optimization method we can say. So like this algorithm works in case of resource allocation. So that focuses about performance optimization also. So in cloud computing, ACO optimizes cost, performance and load. So these are all the advantages of this ant colony optimization algorithm in case of performance optimization. It doesn't mean that it is going to use only this algorithm. So we can go for any algorithm also. Like earlier I was discussing about deep reinforcement learning algorithms. So again it is going to be what a small thought about which algorithm can be used. That is depends on the architect designing the cloud. So next one is about the security, that is the major concern. Nowadays in all fields and all platforms you are facing is about the security. So AI enhanced cloud security. So these are all some points regarding this cloud security. So continuously monitors the cloud system, identifies threats to real time and automatically responds before damage. So rule-based reactive signature reduction, manual analysis. So here whenever we are not going to have this AI algorithm in cloud computing in terms of security, it is almost predicted based on the rules that is defined. So whereas in case of AI, it is not predicted, it is rather it is going to predict based on the pattern or sequence we can say. So for example, if you are talking about number of login attempts in case of banking. So for example, if any hackers or unknown person trying to log in into the banking account. So normal person, what will do if I am having the account? So my login pattern, the AI predicts. So whenever I am going to log in, how many times I am logging into my account? What is the time I am going to log in? So this pattern is going to be fixed or going to be accepted by the AI algorithm. So for example, if my account is being hacked, so the pattern actually differs by the hacker. It is not going to be the same pattern which I am using. So hacker may give multiple attempts for login for a particular time period, or he may trying to log in at the mid time. Again, it is going to fix the number of transactions that is being happened by the hacker. So based on this pattern, it is going to take the action. If it is abnormal, which is away from my pattern to my account, it is going to block that account and giving information to the administrator or the particular user. So like this, AI will predict the number of attempts in case of so AI basically behavior based predictive detects 0-day attacks. So that is what I am discussing now. Just a simple example I given. Again, it is talking about the network traffic, any malware or phishing. So these two will degrade the performance or degrade the network flow. Again, it is going to predict all these things. So real-time attack detection. This is just an example, that is DDoS example is given, distributed denial of service. this is so. For example, if you're going to consider in peak hours, AIs have some pattern in peak hours. For example, if you're going to talk about evening 6 p.m. to mid 12 a.m., so that is going to be the peak hour. So in that peak hour, AI is having the history pattern, so that the number of requests or number of users will not exceed 1 lakh, for example. So in some day, in some attempts, what will happen? The number of users, number of requests suddenly rises to 10 lakhs or 15 lakhs. So in that case, AI will not permit all those requests. That is, it is called as a peak fake traffic. It's in the sense this persons, that is hackers, what will do? They will inject the malware in our network, or they will do the phishing also. So filtered malicious. In this case, what is happening? AI is going to filter whichever considered to be malicious and legitimate traffic. As per my example, this is 1 lakh. Clear. So this is 15 lakhs, 14 lakhs. This is going to be considered as a malicious attacks or malicious attempts, we can say. So 15 lakh attempts are there. In that, AI filtered only. The AI is allowing only 1 lakh. So this is what the real-time example which is giving the impact of using AI. In case of absence of AI, this is not possible. So by obviously what will happen, the network will get jammed and none of the responses will be given to the users. So automatically the crash will happen, the performance will degrade. So this is what I was discussing about malware and phishing identification, email example also. So what it analyzes, email content, attachments and download files and URLs. So earlier I was discussing about attempt to my account login banking. So this is another example which is called as email. For example, I'm having my mail ID which is predicted and it have a pattern which is fixed by the AI. So any fake attempts or any fake mail I'm receiving, so it is going to identify email content, attachments and downloaded files and URLs. So these are all the parameters that AI is going to consider whenever any mail is being sent. So this is one important word. So for example, if I'm receiving the mail with the keyword invoice due, urgent action. So means what? I may think that my invoice is getting pending. I mean urgent to do that particular work. So in that case, what is happening? If I am not aware, what will I do? I will respond to that particular mail and all my information will be passed or leaked to the particular attackers. So this kind of words will be filtered. This kind of words, mail that are having is being filtered by AI algorithms. So AI, what are the action will be done? AI quarantine. It will quarantine the email. It will completely block the email, remove attachments, alert participants, and block sender. See the last one is going to block the sender as well. So this is the impact of AI in case of security. This is not that much fruitful whenever you're going for this AI. Account compromise. So that is what I was discussing. Account compromise. So combined impact and the capabilities summary. So what AI does? So threat detection. What is the action will be given by this AI? Monitor logs, network traffic in real time. See, these are all the action taken by, for example, malware filtering, behavioral analysis of files, emails, block unknown malware. These are all the actions carried out by the email. As a result, so we are going to get good performance as well. That is uninterrupted, authenticated responses or requests, we can say. So why AI outperforms legacy detection? So traditional detection, AI driven detection. See the first one, detection. It's detect only the signatures, whereas AI will detect about this behavioral 0-day capability. Response time, minutes to hours, whereas in case of AI it is seconds. False positive is high in case of traditional, whereas in this case it is not like that. Human dependency, again the same, it is, whereas in case of normal, that is traditional cloud, it is heavy. In case of AI, it is minimal. So these are all the differences we can say. And this final parameter is about the cost. So as an introduction part, I said that whenever or whatever the service we are going to use, whether it is a performance or resource utilization or green computing or edge cloud computing, we are going to focus about the costs. So as a vendor, as a business, whatever the service I'm going to provide, whatever the service the cloud provider is going to provide, their major or one of the major consideration is going to be costs. So cost plays a vital role in all the aspects. So cost optimization, how the cost optimization will be done in case of cloud. So usage data analysis, again this the sequence of steps that is being carried out by AI algorithm in case of cost optimization. So usage data analysis. So it is going to log what is the usage for that particular resource by the particular time by that particular user. That is what usage data analysis. Demand prediction. Apply ML model to forecast near-term demand. Of course, that is the core role of this ML algorithm or AI algorithm is going to follow. That is demand prediction. It is going to predict based on some model. And third one is correcting. That is making adjustments to the previous or earlier allocations. So cost savings. So adjustment is as the result of adjustment we can save the costs. Of course, in previous case also we are discussing about if 3 servers are there and only 2 server is getting the load and third server is being idle. So in that case we can remove that particular server. So if if by removing one server, the costs for that particular server is being reduced. So that is what it is mentioning. So continuous monitoring, key metrics, AI watches. So in case of cloud, this particular service is done by that is CloudWatch. We can say we can have one service which is called as a CloudWatch. The same thing is being done by AI with some more enhancements. We can say that the first one is CPU utilization. It tracks the utilization time of that particular CPU or load of the particular CPU, memory usage. So these are all the 8 parameters by which we can reduce the costs. So these are all the 8 parameters by which we can reduce the cost. First one is CPU utilization and second one is memory usage. How much amount of memory is being used and how much amount of memory is being not used. Storage growth. Network bandwidth, whether we need to increase the bandwidth or we need to decrease the bandwidth based on the demand. Application traffic. So here application traffic is refers to number of requests that is being given. Best practice correlate signals, map matrices and teams. So these are all the key parameters which give impacts to the costs. Of course, cost requires the forecasts. So that is why forecasting uses spikes. Why and what is it actually? So key benefits. So as a output of implementing AI algorithm, the cost saving is 40% of cost is being saved as an average. So here the simple example is given: 100 virtual machine running full time. So here instead of running 100 virtual machines in all time, it is going to flex or it is going to give the adaptiveness between 30 and 120 based on the demand. So monthly cost is 8 lakhs here given, whereas whenever you are using this AI, it is going to ranges from 5 lakhs to 5,50,000. So again here we are reducing around 2.5 lakhs. For instance, for example, for a particular period, for a 1 week I am talking. So no demand based scaling. So whereas in this case of AI, it is going to forecast or it is going to predict so that it will be the adaptive one. So here again a simple scenario is given. Resource type virtual instances allocated, used and recommendation. Block storage allocated, used. Migrate cloud volumes into lower cost things. That is what are all the actions that can be performed based on the resources what we are going to provide, that is virtual machine, block storage, object storage, containers, reserved instances. So this all talks about what is the impact of AI. So again this says about the cost savings in case of different resources, virtual machine, excess storage, inactive containers and all those things. So again this is another example this EdTech platform results. So whenever we are going to focus about any online exams, so monthly cost, it is going to be 12 lakhs before using AI. Whenever you're going to use this AI, it is going to reduced as 7 lakhs. Okay. So downtime, so frequent on peak days, it is zero downtime. Resource efficiency low, where it is high. So overall, it is going to save 42% of costs. So that is what we need to follow in case of AI algorithms. So we have seen about what is the impact of AI in cloud computing nowadays. Thank you all.